Okay, we just start so that will join us on the call. So good evening, everyone. Good morning, good afternoon, wherever you're joining us from. We are welcome to the Tangerine Community webinar on incremental data pipelines with MI-ETLx. Before we start, I'll just quickly introduce myself, then I'll walk us through the agenda of the day. My name is Najeeb Sulaiman, currently the founder of the Tangerine Community. Which means I'm the #1 servant of the community. Yeah, I currently work as a data engineer with Jaguar Land Rover UK. So to give you a bit of background for those that are joining us as guests or joining the call for the first time. So data engineering community is a community of data engineers across all levels of experience, aspiring data engineers, beginners, intermediates, seniors, and it's a platform where we all come together to learn and grow together. So for beginners, you can imagine it's overwhelming to start data engineering as a career. It's one of the not so easy to start our career journey. So, and it means that aspiring data engineers, beginners can have access to more experienced data engineers to kind of leverage their path towards becoming better data engineers as well. Yeah, so we kind of come together to learn and grow together. That's what we do basically in the data engineering community. And this webinar is one of another episode of our webinar series. We started to kind of share knowledge among ourselves to keep growing together, which is called Data Engineering, Demystifying Data Engineering. So, which is a webinar series we've been conducting since beginning of this year, January. So this is the 6th episode of this webinar series. And today we'll be having another interesting topic, which is incremental data pipeline design with MI-ETLx. And doing justice to that is one and only Pascal Mikahama. He has been with us previously at one of our episodes, and we are so glad to be having him once again in this episode of Demystifying Data Engineering series. So we so much appreciate him. So he's someone that, loves giving back to the community, loves sharing knowledge, and I'm very confident we are going to be learning a lot from him, with his wealth of experience across different technical domains. Just to give a brief introduction about Pascal. So Pascal is currently the Chief Technical Officer at Wowzy, which is an influencer marketing SaaS platform. So where he leads the technology strategy, systems, and innovation. So he has over 15 years of experience in data and software engineering strategy and management. Wow, 15 years ago. That's a long experience under his belt. So spanning different domains and industries. So you can imagine having 15 years of experience and counting. So he has a wealth of experience under his belt. Can you please react to that? Let's just give Pascal reactions. You can share your emoji, love emoji, clap emoji, just to properly appreciate Pascal and welcome him. This is a very good profile. So Pascal, thank you so much for joining us once again. It's a pleasure. Every time we come around, we know we are going to be learning a lot from your experience. And we so much appreciate your willingness to always, speak to us, share your knowledge with us, and give back to the community. Thank you once again. So this session is going to be roughly 1 hour, just to give us a bit of preparation. And there is a demo on this webinar as well. So there's a file that has been shared. So I'll be sharing the file, the source code files in the chat of this webinar. So in case you want to follow along. Yeah, so without taking too much time, I'll leave the floor open to Pascal to walk us through incremental data pipeline design with MI-ETLx. Thank you, everyone. Thank you once again, Pascal, for joining us on this call today.
Okay, so welcome, guys. Sorry for that initial delay. So today we're going to be talking about incremental data pipelines. Why incremental? I mean, today, what does a data engineer do? So many people have so many ways of saying it. How do you do that? What the fundamental thing a data engineer does? I think the fundamental thing a data engineer does is to move data from a source to a destination. And in moving data from a source to a destination, a number of things come in. What do you do? What tools do you use to do it, right? And anybody who knows me knows that I don't do like tools, right? Like the elaborate tools that we have out there. These tools work, but I feel that the data engineer should be able to actually engineer their pipeline, right? So incremental data pipelines with MI-ETLx is one of the ways I, with two of my former team members, have tried to demonstrate this. So basically, data engineer moves data from a source to a destination, right? And we know we have two broad types of databases, some SQL and some non-SQL, with all their restrictions depending on what you are trying to do. Today, technology today has gravitated towards speed and latency, okay? A good web application, a good platform is a platform that not only works, but works in an efficient way. It's fast. You don't want to log into somewhere, it keeps rolling and rolling and rolling, right? And that makes NoSQL systems very attractive to engineers because NoSQL systems are mostly document-based, right? They are columnar, meaning that retrieval of data is usually fast using them. So these are the type of sources, data sources that are becoming more and more prevalent today. This has informed why MI-ETLx, and I will tell us the full meaning of it. So a data engineer moves from source to destination, but what they do from here to there to get that done is, you can call it a point of debate or whatever you choose to call it. But what matters is that you have successfully moved your items from a source to a destination. I will play a video that I shared sometime on LinkedIn. So hopefully you saw you saw the video I just showed. Consider those two performers, two different types of data engineers. The whole point is to get to that top, right? The whole point is to get to the destination. Did two of them get to the destination? Yes, they did. How many times did the first guy do it? Around 4 shots, right, before they got to it. But the thing is that they got to it. The second guy, that's calisthenics. I mean, I don't even think I can do that. I can't even dream of doing that. But you can see he took some time. It took a lot of effort, but it was one shot. So what I will usually say is that what I feel is that an efficient pipeline has as little points of failure, as little possible points of failure as possible. That first guy that did it 4 times, in as much as he's effective, he could have failed on 4 different occasions. Okay, but the second guy, yes, heavier lift, more tact, is more technical, but one shot. So passing it is a 50-50. That pipeline, if that's a pipeline, is a 50-50 chance. You get it or you don't get it. However, so the chances of success is 50%, so to say, right? It's 50-50. But for the other person, you have to divide it into 4, 25, 25, 25, 25. So 4 different points they could have failed. As long as you keep getting all 4 points and there's no failure, everything is good. You don't have to bother. However, from experience, having been around this thing for some time, those 4 times will be 4 different cost areas. And going by the tools that we have in the market, these tools will make you do it in a particular way. Again, don't get me wrong. They are not bad. They are not ineffective. They work. I just feel that they are no longer engineering stuff, right? We are putting things together and we start creating a whole lot of complexities. We start hearing about data lakes when we shouldn't even touch them, right? Data lakes are very important parts of the data pipeline, especially when your data is a lot. But let's not dwell on it, on how of the things a lot, and look at the actual thing that I wanted to speak about today. So, MI-ETLx, what does MI-ETLx mean? I go into my slide presentation again. Now, we'll try to attempt an overview. MI-ETL, engineers who have worked close to me will know that I'm the poorest guy when it comes to naming things. I call it whatever comes to my mind or something that makes me remember it. And as I get older, I think I will get worse at names. So MI there is Mongo Incremental, ETL is incremental extract transform. Now, so ETL extract transform load. Of course, every one of us knows what ETL means. But the X there was put there because the way we've built this, we figured that the engineer could actually make this ETL or EAT, whatever they want, right? Now, the origin of this was that I was working somewhere. Meanwhile, I might have started this, but there are two engineers that I've teamed up to finish this. They actually caught up with me after we left where we worked, and they were interested. Let's finish this thing that we started. So Nelson and Joseph, I'm sure we know them on LinkedIn somehow or in your data engineering community group. So this started as an effort to bridge the gap. So it started this way. Incremental loads are fine when you are small, okay? Sorry, full loads are fine when you are small. So you have a source, you want to move it from that source to a destination. You choose your destination, you have your source given to you. Now, initially you might have a 1 MB database that is a source, 100 MB, 1 TB, 1 gig, 5 gig and stuff. And copying everything from source to destination might be convenient initially, but over time, there is no other way it can happen than getting bigger and bigger and bigger over time. So if your pipeline ran 5 minutes from inception, as your platform keeps churning stuff out, it will go from 5 to 10. So a minute, 2 minutes, 3 minutes, 4 minutes. Before you know it, it has gotten out of hand, and your pipelines are running such that you hold your breath, hoping that it doesn't break at a point. So it might be easy for you initially, but over time, you find out that incremental loads help you. Incremental loads can be implemented in a number of ways. The whole point of incremental load is that when you come to your source DB today, let's say there are 1 million records from inception to when your data pipeline starts working. 24 hours after that, there can only be so much data that was added to it. Why do you need to carry the whole 1 million again? There's no point, right? Is there a way you can find the guys that came new, the guys that were added 24 hours ago? You take only those guys because you have the 1 million already. There's no point doing that. You just continue killing memory, killing storage, troubling your IO, and just mounting a lot of cost. So it's a simple calculation. If your pipeline runs 12 midnight today, let's say it's the first full load, it takes everything historically up to 12 midnight of today. Tomorrow, the only things that have changed will be the things that were added from 12 midnight yesterday, or the things that were updated. So if you find a way to tell your DB, please give me everything that is new since a particular point in time, then you take it. You find out that if you succeed in doing this, there is only so much throughput you can get in your data pipeline. If you are a very big company, you probably won't get more than 10 gig, right? But those are very big companies. For the everyday companies that we all work at, I believe 99% of us here probably work in companies that don't produce that much data. At most, you have 5 MB daily, 100 MB daily, if you are really, really doing stuff. We are talking mostly textual data here. So it means that if you find a way to make it incremental, every 24 hours, 2 times in 24 hours, 4 times in 24 hours, your pipeline will always tend to move a particular amount of data that is very, 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 very manageable every time. And breaking becomes something of the past, or possibilities of breaking go down. So that's the whole point of an incremental system. And MI-ETL is originally written to have a Mongo source and an AWS Redshift destination, or any Postgres, any warehouse that is Postgres based. Redshift is a glorified Postgres database, so to say, in a columnar fashion. So that's the first part of it. What does MI-ETLx bring to the table? 2 major things. First is that it does incremental extraction and loads the incremental guys. That's one. The second one is that it aims to give back the power to the data engineer. Okay, I believe the versatile and very effective data engineer is the guy who finds a bespoke solution. Bespoke is what works for your organization. And you know, the funny thing is that at the end of the day, every organization has that same need. Move my data from a source to a destination. Every other thing in between will be called calisthenics for people who do that type of exercise, right? Now, moving forward, I'll try to describe to us 3 different steps taken in MI-ETLx, right? So this is a Python package made up of some modules put together. I mean, it's your regular code put together, and that's actually what every tool is, right? They've put it together, wrapped it in a GUI, made it very beautiful, give you login and stuff like that. So what are the basic things that MI-ETL do? First, it extracts from Mongo, and Mongo being a NoSQL system, which is really very popular for transaction databases today. It doesn't have any real schema restrictions. So you tend to see very nested items, right? Some very well planned ones are flat, but there tends to be a lot of nesting. So the very first thing that MI-ETL does is to extract from Mongo and straighten it out. Kept it as straight as possible. All the nesting, it brings it out and straightens it out into a very flat table. That's the first thing it does. Secondly, it has an optional step, which is loading it into a data lake. And this is only done if this system is anticipated to have some SCD functionality, right? Slowly changing dimension. Now, how does it achieve this? Imagine you are always moving 100 records from source to destination. So MI-ETL helps you to move the 100 records from source all the way to the destination. But think of it, what if there is an issue at a point and you find out that your 1 week worth of pipeline movement has actually been corrupted, right? Where do you get this? You have 2 options. Either you go back to the database that you are doing this and try to recover from there, something that is possible, but your core engineering team is going to fight with you because they don't want your transaction database disturbed a lot. So what MI-ETL does there is that if you activate it for that purpose, what it does is that it takes it first from the source, straightens it out, and dumps it in a lake for you. Coming with it out of the box is access to AWS S3. So if you set it up, it dumps it on S3 and then loads it on your data warehouse, right? I'll show you how it handles duplicates, as well as whether the data lake, which is S3, could keep duplicates or not. So, and on the third step, what it does is to load the extracted data into the warehouse in an update fashion, okay? This means that it caters to changes as well as entirely new data inserts. So the way it does this is this. Because the 100 rows of record it pulled out might not be 100 new rows. There might not be 100 new insertions. What it does first is that it gets to the destination, creates a replica table of its destination when it gets to its destination, then loads what it is coming with into the replica table. Then what it does is that it tries an update. It tries to find every item on the replica table that is existing on the other guy, okay? On the main warehouse. Let's say it finds 30. What it means is that this 30 that came from the source but already have an existing key at the destination were updates. What it does is to update, is to override the 30 and add the remaining 70. The way it does this is that in a transaction, it deletes the first 30 that it found and then loads the 100. Okay, this is exactly what it does. And since it's in a transaction, I know you must have shouted, why delete it, right? But since it's a transaction, everything must succeed before it now commits it. So if any row, if the deletion or the insertion fails, everything has to be rolled back. So this is exactly how MI-ETL achieves an update. So anytime any amount of data it takes in, it's going to add the new guys and replace the guys that were old there. So that's exactly what MI-ETL does. And I mean, the beauty of it is that this is another Python module, meaning you can actually take it, strip it down, add a lot of functionalities. That's exactly what this is planned to achieve. So you mustn't do it exactly the way MI-ETL wants you to do it, but MI-ETL believes it has a rather good way of doing it, but you can actually take classes away from it, augment it. For example, you can take this, make it support a DynamoDB source, for example, which is something I've almost finished because where I am now, we use DynamoDB predominantly. I mean, you can make your destination instead of AWS Redshift or a Postgres database. You can make it BigQuery, you can make it Synapse or whatever you have out there. So this in a nutshell are the steps that MI-ETLx undertakes. So why the X? X simply because you can make it ETL or you can make it ELT, any way you want it to be. So so you might now be asking, how does I mean, basically, you can change your MI-ETL is written in such a way that the engineer can actually extend a number of things there. Instead of being just a Mongo source, you can make it DynamoDB, Elasticsearch, whatever you want it to be. I don't know whether you heard when I spoke about the schema resolution that it does.
No.
Okay, because I mean, every data engineer here who has had to build a pipeline would wonder, how does schema resolution work? So what MI-ETLx does is that the first time it runs, what it does is to extract the data, straighten it out, put in a data lake if you have an SCD step to it, if you have enabled it. And what it does is it goes to your destination, tries to find the table name that it writes to. If you can't find the table name, it predicts that the table you are writing has the same name as your origin. Now, if it doesn't find it, it creates a new one and onboards the data. Subsequently, what it does is to go to the source at each second run, get the data again, go back, check whether the table exists. If it exists, it gets the schema of the table and compares it with what's incoming. Okay. Now this is where it does something that is interesting. It will always keep to the schema of the first time. That's how it resolves schema. So if the first time it created 10 different columns, what will happen is that the next time, if it finds 12, it's going to pick 10, ignore the new 2, and spit out a report saying, I saw 2 new columns and I didn't do anything about them, right? That, so it doesn't go to fail. So your MI-ETL will always finish the job once you can find the source and also reach destination. Now, in cases where it gets item from the source and some rows are missing and some columns are missing, what it does is to create the columns on the fly, null them out before it takes it in. So either way, MI-ETL plans to succeed. That's how it handles its own data resolution. So, and every time it's going to give you a report after each run saying, I saw these new columns, if there are new columns. If there are no new columns, it just keeps quiet, tells you how many tables moved, what time it took it to do it, and so on and so forth. So we felt that it telling you that a new column has come in, but it ignored it, instead of going to fail. So uptime is important, but visibility to the engineer who has built this is very important. So 2 new columns have come in. So it's an opportunity to speak with your core engineering team or the people who manage the transaction table. What's this? Do we want to onboard it? Do we want, does anybody downstream need these new columns? And if they need it, then that's the update that the engineer is going to do, and the guy keeps moving. So under any circumstance, MI-ETL desires to actually finish the job and give a report of what happened. So like I said, it's designed to work with AWS first. Okay, I think I've shown this. Then finally, before we start the demo, this is how, okay, I think I've written about MI-ETL. You go to this link, when this slide is shared with you, you can see actually the whole thing I just explained and how it achieves it. Finally, this is what the infrastructure or the APIs under MI-ETL looks like, okay? There is a loader, there is a utils package, there is data extraction, there is the connector, there is the schema, and there is an exception handling system. So without much ado, I will go straight into demonstrating. So I have prepared a notebook here. How do I make this guy to go away? So I can see the top of, all right, cool. All right, so I'm going to spin up my guy. If you use Jupyter Notebook, I have a sneaky way of helping you. I mean, if you don't know this, there is a way you can open your Jupyter Notebook from exactly where you want. So you can see I'm at so documents, data engineering community, and this is dress rehearsal. So yeah, I actually planned this before we started. And I have a virtual environment here. So all I do is to come to the actual folder I want, because I've set Python and Jupyter to my path, PATH. All I need to do is to type Jupyter Notebook here. And I don't have to do any fancy navigation because the notebook is going to start out of here. I have the latest notebook, and I must confess, I don't like it. The older one looks better. All right, so this is, so I have two notebooks here, one that demos MI-ETLx itself and one that inserts data into MongoDB. If I open this guy, it looks so much strange. So I've put some steps in here in case you have not done some of them. I've done all of this before already. I pip install virtual env. If you're wondering how you can install stuff from Jupyter Notebook, just start with it, an exclamation mark, and it will act like your command prompt. Move this. Okay, I can see I already activated the virtual environment I created for this up here. I will tell you how I got to it. So if you don't have this pip install virtual env, create one. I called my MI-ENV. I won't run this. We'll just go through it. For you to touch a kernel here on Jupyter Notebook, right, you have to put a Python support for it, so you can create your own environment that you can switch to. Okay, that's what this guy does for you. Here is me actually creating the environment, tapping into the virtual environment in the Jupyter Notebook, so I can have that option where I have my Jupyter Notebook up here. So again, I will run this because I already have it. And this is the step to switch the kernel. Just come to kernel. Go to change kernel. So I have one of my friends here. So he connected and we had some echo. So choose the env that you want. You can see my default env here, Python 3 IPY kernel, but I have my default one. So I already set it to always start with that environment. Okay, so once you do this, I presume the virtual environment is going to be brand new. So you might want to put Mongo there if you don't have Mongo. And this is, so MI-ETLx is not yet on PyPy, but it's on test PyPy. So this is the address you want to grab it from on test PyPy. Once that's done, so I want to make sure that we feel that this is actually working. So what I'm going to do now is I have opened up Compass here. I want to drag it to the screen so we can see as the things move around. So I have Compass here. Okay, so one information I didn't give about how MI-ETL works is that after each run, MI-ETL takes some data about the last run. It takes, okay, let me open it so we see exactly what it writes. So after each run, it writes this object that you are seeing here, okay? It takes note of when it ran, the exact milliseconds it ran, and also the dates in this format, and also some information about how many tables moved, what succeeded, and so on and so forth. But the most important one here is the time that it ran the last time, this timestamp. And what happens is that the next time it starts, it actually picks the last time it ran so that it knows where to engage the uplog. So I think I didn't talk about uplog. So how is it able to figure out where was the last time? Mongo has what it calls uplog, where it keeps a copy of every single change that happens. Every DB has it. It depends on how it behaves. Dynamo has Dynamo streams. Dynamo is limited because I understand Dynamo streams last only 24 hours. But Mongo is always there. You just have to give it more storage if you want to keep more. So what happens is that it picks this and is able to actually connect to uplog, which is a record of all the changes on Mongo, and start pulling it from that particular time. So that way, every single change that happened, it's going to get it. Now, look at how it picks the time. It doesn't pick the time when it finishes, when it starts, because if it picks the time when it starts, if it takes it 30 seconds or 1 minute to run, some things would have changed by then. So what happens is that immediately it starts, it picks up that time, okay, and starts taking it. By the time it finishes, the time it has is the start time. It's important that it is the start time, otherwise you are going to have some lapse that you miss some data. So the start time is what it writes. And it only writes it finishes and works with it if the loading succeeded. So if it succeeds, it writes this and tells you true if there were changes, because you could run this pipeline and nothing changed. So loader here, false, is telling you, okay, I want there to get things, but there were no new stuff. This is one way to figure it out, apart from the result it gives you after it runs. Then I think I'll just go ahead and import some of these things that I'm going to need for it. Of course, I've put all my important things in my environmental variable. So when you get this notebook, I create my connection here. I have my full URI to the Mongo with all the credentials I need stored in my env as this. So I pick it up as con. I have to give it details of the destination it's going to. This is where I said I don't trust this new guy because I think something is missing here. Okay. All right. Okay, so I do this, I get this and get connected. Okay, what this does is to go and touch the Mongo and make sure it's connected. If it's connected, it tells me yes, it's connected. This is where I can swear some things are missing. I have the details for connection to the destination here, and I can't find it again. Dear. All right, so but let's keep going. Let me see if I can find it fast enough. Now, to start, watch the things I had to pick from MI-ETLx. From MI-ETL dot connector, I bring in the source. Source is what helps me connect to the source DB here. From data extraction part of things, I get data extraction, which is the guy that actually brings in this stuff. So if you're an engineer and you want to have more power with what you have extracted, right? You want to target data extraction from data extraction, and you can augment the class and add some more things. For example, decide to do some stuff when you extract it and so on and so forth. Then you have the loader class from loader. This is also where you can change some of its behavior when it goes to load your destination. So I'm going to, so now, okay, let me connect again. It tries connection. When it succeeds, it tells us it has succeeded. Now, how data extraction works is that you give it the connection that you have created to your source. You tell it what to extract. This is where you can actually, control what happens. Me giving it an empty list here is saying every table in the destination, bring out all of them, right? And I tell it what DB am I interested in. There's a DB called sample analytics, and that is this guy. Sample analytics, that is it here, right? And you can see I have a table called customers. This is my target. Now, to extract, there are two ways you can do it. So remember, pipelines can fail. You could find out that some things have changed. For example, let's say there are 2 new columns that have come out and you have adjusted your destination and you want to start extracting, not just from the last time, you want it to start from a particular date. So we have a backfill utility here. where it can go in and start not from the last time it has written, but from this particular time, because it understands you want to go back in time. Now, once I create a data extraction object, giving it all the things I want it to get in terms of the things from the source, I will now extract the data by calling extract uplog from this data extraction object that I created. So I'm going to run this now. So when I run this, I expect that no new thing will be seen. Okay, data extraction started. And after it's done extracting, see that extraction ended. I mean, yes, it's as simple as that. This is all you need. It's just Python code that connects to MongoDB, knows the table, knows the database, knows where you want it to get, and it just goes there to get it. Now I'm going to try to pick the data that I got. I expect it to be empty. Yeah, exactly. It got nothing. Why? Because I ran it last night before I came and I've not put in any new data. But I want to show you that if I go back here and decide to rerun this, the backfill. So let me use this backfill and tell it to start picking things from 2023. I actually don't have a lot on the database. So what happens is that when I run this again, data extraction starts, and at the end of it, I expect that I've gotten something because I went back in time. Don't worry, it's 2023, but there's not a lot on the DB, so it's not going to, yeah. So I try to pip it now, and you can see that it actually pulled in a table called customers, okay? What MI-ETL does is that it brings it back as a data frame, right? That's one thing I want us to change about it, because I feel data frames are too heavy. There's a way we can make it closer to native types in Python, right? That would be better, so that making it a serverless resource, for example, becomes easy. So if I pip the table, I can see the first two columns here. I just want to see, I like to eyeball my stuff to see what's happening. So there are actually 40 rows on this guy. Now, what I'm now going to do, and I know it's going to fail, is to try to initialize my loader, because I can't find my connection to the destination here. I'm sure I should be able to. So if I try to load this now, okay. So you might be wondering, why are we still giving the Mongo connection in the loader? It's simply so you can write us the summary of what happened at the end of the day, and also write the time that it started and ran successfully. Now, the extracted data, if you remember, is held when we run the data extraction up here. Okay, this is what we have here. So this could come back with as many as 100 tables, 50 tables, but in this case, it's just one table because it's a very small database. Now, once I do that, the next thing I will try to do is to use the run method in the loader object I created to onboard it. Notice that data warehouse here is true. This is the actual destination. Data lake is false, and extracted data is the data is the extracted data we want to give it. Now, assuming warehouse is true, I would have given it AWS, right? So this, even if I remove this guy, I will still be fine, because by default, AWS is none. All right. Now, running this, this is where I will tell you to fail, because it doesn't have the connection to the DB. Yeah. So you can see all these things are not there. Let me see if I can quickly grab them from the older notebook. It shows when I was cleaning it up, I lost that data. Okay, so let me see, data warehouse 2. Okay, I hope I'm able to find it fast enough. Can I power this on the phone? So okay, I think I have it on WhatsApp somewhere. Okay. I'm opening this one. So Najeeb, I think if there are some questions, we can take it so I can get this and we keep moving it. But basically, so what we try to achieve with this is that we only move stuff that has changed, only stuff that has changed, and it's able to handle itself when it sees duplicates. It aims not to fail, by doing schema reconciliation by taking only the things that he knows. If he doesn't know it, it's not going to fail because of it. It's going to take only the things that he has and then keeps going.
All right,
Okay.
boss. There's echo. Hello.
Yeah,
Okay,
there's echo from my side.
okay, it's better now. I think I'm hearing myself before initially. So yeah, so while you are checking that, if there's any question, please signify so we can take the question simultaneously while Pascal is trying to grab the connection details. May I go ahead?
Okay. Yeah, thank you very much. So one quick question. I mean, the code behind this tool, is it open somewhere?
Yes, it is. Let me see. And I believe also Joe and Nelson. Oh, I know it's my repo. Let me make sure it's. Let me see. So this is it here. I think it's open. Once you go to GitHub/Ife, which is my handle, see if you can find it. If you can't find it, but sometimes it should be open.
Okay.
Yeah.
Okay, thank you. Nelson.
All right. Yeah. The name is Uplogworks. Is the initial name I called it. I told you I'm the lead
Nelson has
developer.
shared the repo
Nice.
link on the chat.
Yeah, I got it.
Ahmed.
Okay, so thank you so much. This is a very wonderful one. I have two questions. I think Emil asked the first one because I think this is what a lot of people would like to also contribute to make it something bigger for us. So my other question is, when you after that extraction, where do you keep the data? So I can
The
ask
extracted data.
Yes. So when you extract from source, do you keep data somewhere, or it's just stored in that variable extracted and something like that
Yeah,
before
it's
you
just
push it to
stored.
the destination?
No, yeah, it's just a memory. It's just a memory, and it's deliberate because once this guy is in play, it's estimated that your throughput is going to be really small. Okay.
Okay. So how do you handle initial load?
Initial load.
Yes, before you know if you are doing an incremental load, expect to do an initial
Okay,
load first of the system. And
exactly. Very
let's
good.
assume that the load is actually they have very amount of data. That first load that you do, obviously this is perfect when you are doing the incremental, because if you are putting in memory and what you are getting from the incremental run would not be that much, then it's awesome. But my concern is that initial load and keeping it in memory for that.
Nice. So, what will I do? What I will do if I get a greenfield job that requires me to do this is that I will still do it with me here, right? But I will have, depending on the size of my source, depending on the size of my source DB, I'm going to want to get a fat machine for it. That's what the cloud is for now. Rent one big machine, do it even if it takes me for 8 hours. I move the initial guy and eventually take it to my, by the way, I've already provisioned this to work on Lambda and it works perfectly. So that's how I will do my initial load. But if you're lucky, you are in a small company that has very small stuff, I mean, you can just start it out from day one, because no matter the size, it really doesn't matter. But that might not be entirely correct, right? The size of your initial load might make you run for hours, right? So when it comes to that, maybe we look at something like, some of the guys that can handle bigger loads, so to say. But this guy is aimed at your incremental. But my answer is that I will still use it for my initial load, but I will not run it on the environment I intend to keep this guy. Because in deployment, I don't even want this guy to be on a full machine. that will go against the whole plan for this.
Mm-hmm.
I'll still have it on
Mm-hmm.
a system that it can run small incremental guys.
Okay, that's awesome. So last question. You mentioned X3. Maybe more of an opinion. I feel like that part is a very, very awesome part where if there's a need for you to do probably backfill or something, you can always go back. So for me, it shows that the person who designed it is an engineer, right? That's one. And then I also feel,
Exactly.
yeah, I also feel like the parts where we can do runs for huge amount, that initial run for huge amount of data, I think we can leverage that X3 for that. It's just an opinion.
Exactly.
I think
Beautiful,
about it.
beautiful. Exactly. Yes, it could actually do that. You take that your initial. Ahmed, I will not do that one, right? But that's a brilliant idea. Why I won't do it is that I'm going to need something to connect to X3 to bring it back, and I don't want to get an extra tool. I want to start
Okay.
and finish it. Yeah. But yes, that's a way. That's a way out.
Okay. All right. Thanks,
By
man.
the way, how did you manage to have two hands up? I see two
No, I
on your.
don't know.
All right. So
it seems magic, and yeah.
all right, and just a little more on the S3, right? So if you think about it, S3 will have duplicates. That's how it's meant to be, right? So if you go get the initial 100, sorry, if you get the 100 from today, and 30 are updates. If you have the S3 leg of it, the data leg of it, you dump the 100 pieces and go into your warehouse and do your update. You come the second day, you have some more. Chances are that some of the guys you have already written came in an update to S3. So it's expected that there will be duplicates. So your warehouse will always be up to date with the source. However, if you want to see a picture of the evolution of your data, that is where you want to go, because S3 is going to show you what this row was on this day, second day, third day, and fourth day. So yes, it was a very deliberate move to put that guy there, because sometimes data audit, this is the only way you can get it. Because if you keep updating, you never know the former state of the guy. That's why it's called an SCD. I don't know what actual SCD name they're going to call it, but I know that when I conceived this, I knew that I was trying to solve a very practical problem I was facing. I could ask, what was this data at this time? Engineering cannot even answer you that unless they are writing history. But with this system, MI-ETLx can actually tell you the story of the evolution of every row on your system.
Amazing, amazing, interesting. So have you been able to grab the details, or should go ahead with still
Yeah,
ask a question?
let me still, let's keep with the questions so that we don't keep quiet at a point. I've already
Okay.
opened where it is.
Okay. Sure. Any other question? Let me check the charts. By the way, someone said just this is not a question, but jokingly, someone said Madam should not allow you to name the kids.
To do what?
To name the kids.
You need to see their names. I mean, it's good I have help, right? Because you can't claim to know everything you do, otherwise you cause disaster.
Yeah.
Very good point.
Yeah, that's by the way. Yeah.
Yep.
Yeah, I can't seem to find any question.
I'm trying to raise my hand, but I'm not sure why it's not working.
Oh, sorry, I thought it's the old hand. So sorry.
Okay.
Go ahead,
Again,
please.
yeah. Again, thanks for the parts whereby if something got deleted from the source, I mean, we all know what will happen. I mean, source sometimes they can behave dramatic, whereby they just break the downstream. So I like the part there where these undoes that parts, even though they delete something. I mean, it just undo it. But on the other side, whereby if we have more coming from the source, and you said if we have 5 already written, and now we have something changing, maybe it's now 7. So is there any kind of functionality that accommodates that as well, or was it intentional to just leave those two? Because sometimes, those things that get added in the source as well. someone might need it, or for analytics?
Yeah, very good question. So first is, I'm a core engineer, I'm a core software engineer, I'm a data engineer, right? So I know how things break. The first aim of MI-ETL is don't fail, right? Now, because it's a NoSQL system, that is even where you have the very high possibility that what started as 10 columns might eventually go into 12 and stuff. Or in the effort to straighten things out, you may have gotten one that had an increased nesting, okay? So the question is, right, let's take it, let's put ourselves in an organization, for example. When the engineering team adds 2 new columns, what do you want? Do you want to fail, or do you want to be aware that it was added? Especially, I mean, core engineers will not tell you. Those guys will not tell you. I know I fought that fight, but I mean, it's a fight you will lose. I'm sure you will lose, because the business is pushing them. You need to start showing this, you need to do this, do that. So what happens is that MI-ETLx will tell you something has changed, but it still did its thing, right? Because after, I wish I will try to find it so we'll see what it tells you when something changes. I'll try to simulate a change and you see it do it. So what's important is that you become aware it changed, and probably try to engage. If you have a more organized tech team where you guys work together, chances are your core engineering team has already informed you. But if you have tried to solve anything as a data engineer, you know that it is schema change. So you want to succeed, then take those new guys and say, guys, you gave me 2 more columns here. I remember I don't know whether Charles is here. Charles, I don't know what that, Nelson, I don't know whether you met that, and Joe. I mean, after every pipeline, that thing failed because 2 new columns were added. Why can't these guys tell us? But sometimes you don't have that luxury of telling you, because I'm also a core engineer. I understand that they are pushed, right? Joseph Itoba is here. So Joseph will tell you, I mean, these things will always break. So the whole point is succeed, get a report, and figure out what's happening. If you need those 2 extra columns, then you know that you have some jobs to do. Do your migration, add the new columns, of course, null out everything. If they were not existing, the older guys are not going to have any values for it. So that's the way I will handle that. Succeed first, correct later.
And I totally agree.
Yeah. I mean, if you're a core engineer here, you are making data engineers' lives very miserable. Please tell them. We understand you will change stuff, but please let someone know.
You can't trust them.
They can't stop.
trust
Don't
these
worry.
guys.
They can't stop. They can't stop. Don't worry yourself.
Exactly. It's just business. They push them, they push things, they push you. So data engineers, I'm sorry for all of us. You just have to pick up the slacks there.
Yeah. I mean, it's one of those things you have to deal with regardless. There is feedback. I don't know who's seems, let me see, who's not muted. I'm hearing echo. But it seems
Okay, yeah, I
better
think
now.
I've seen my connection details. Beautiful. Yes. Let me bring them over. Oh, yes. Oh, I think they were at the top. I didn't put them in, so they should have been here. I'm not giving out anything yet. They're all on the end. Okay. So that done. My loader has. Okay. So let me do one more run. Okay, connecting, and then I do the extraction. Because I'm backfilling, I'm going to get the older guys, right? And I think this backfilling idea was from, I think either Nelson or Joe. Because I mean, I think the good thing about this is that this was made by actual engineers who have been in a situation, and we try to catch as much of the realities as possible, because these things are not just theoretical stuff. These are companies, organizations who are doing this or that, and we are trying to solve this actual issue that they could have from running their stuff. Okay, I should still have the 40. I initialize this guy. Okay, so the job is now, so it determines that the incoming table is customers. It creates a temp table to do the thing I told you about, and then it does its transaction and it succeeds. Now, The outcome of this run is held here, right? Let's see what it has for us. So it tells us that the data warehouse successful tables were customers, failed tables, none. One of one tables were done successfully. The description is that Redshift load job was successful. New incoming columns, there are no new incoming columns, okay? Now, let me run this extraction again without the backfill, and we should not expect to find anything. Then I will insert some data and we do it again. Okay, you can see it's super fast here because it doesn't find anything from the last time. We pip it, we don't get anything. Of course, this is going to fail because there is no table coming with it. Now, I open this guy where I have some, I can see our time is up. Let me quickly insert some data. I hope I didn't give up anything here. I think I remember checking it very well. Okay, so I do this, and this is going to insert 10 records. So I've inserted 10 records now. Yeah, I use Faker, of course. I can't keep making up stuff. Faker is there for that type of thing. So now that I've done that, I'll go back and try to do the extraction again. No backfill, right? Remember the last time you didn't get anything. So when I do this, it has finished. Very small stuff, right? Just 10. Then I check, I can see I got some stuff now because something changed. And when I pip it, I know that I got some. Let's see how many rows we got. It should be 10, right? And we have 10 here. I initialize my loader and I load it again. Creates a temp table, does a transaction, and everything works successfully. Now I check the outcome, and so I actually have an email item here, but I didn't go ahead to finish it. I mean, it's very simple. You want to know what's happening, what has succeeded. This is one place that data tools, MDS tools are very good at, right? Visibility, telling you what has happened. You can do that by yourself. You can do it. There's no big deal about it. If you open this mailer, you can see that you can actually make your loader to actually send a mail of this outcome to you. And if anything has failed, it will also tell you. This means that after every run, you're aware of what went well, what didn't go well, what you need to do, and stuff like that. So if I say it like they do on, what they call it, at, debates way back in school, right? I said that with these few with these few points of mine, I hope I have demonstrated to you that in as much as MDS is very great, will cost you a shitload of money, you can do this stuff by yourself. You can. And it is not just effective, you can actually make it bespoke, right? Bespoke means exactly the thing you want to do, you do it this way. Antelope data structure must not force you to take it to basket bricks before you come back, right? You can really do this stuff straight out. Will it take you time? Yes, it will take you time. Do you need skills? You need advanced technical skills to do that. And that's why that video shows you see the calisthenics guy that does it once. It's not a joke. You figure that he used a lot of energy, a lot of skills and stuff. So when you can, I encourage you to do this. Build your pipeline. Get the exact things you need. If you can't, no problem. I mean, I understand why many people will use tools. Many companies will employ you to come and do data stuff for them as a data analyst, as a data scientist, and you find out they don't even have this data, right? But they know that data should be done. We should do this and that with data. And what do? You find those tools. You string things together. You buy this one, spin up this EC2 machine, do this one, join here, join here, join here. By the end of the day, for 100 MB, you are paying $500. But this, I mean, if you put this as a Lambda, this thing will run for 6 months and you will not pay a dime. It's as simple as that. All you'll be paying is for your storage on your destination and also for data load. I mean, you can't run away from that one, of course. So, but running your Lambda, we know how much. Lambda. I mean, Lambda is good. Not just Lambda. Any serverless is Lambda functions and stuff. And maybe one day I will share with Najeeb or Joe to share with the team. This has already been provisioned. All the MI-ETL has already been provisioned as a Lambda layer. So all you need to do is just grab this Lambda layer, spin it up there, put your code, and it's done. Najeeb?
Yeah, Thank you so much for that wonderful session. Thank you for taking us through. I call it MI-ETLx because I just spell it out. Just like the way you have your mic is muted.
Oh, yeah, I don't even know how to pronounce it. I know it's an acronym. So
Yeah,
either Joe or Nelson should find us a better name.
just like you have SQL and some people will just try to call it SQL. SQL. So, so I call it MITLs rather than MITLx. So yeah, it's fine. I mean, it's a wonderful project, and these kind of things is what we should really encourage in the data engineering community. You know, to not only be consumers, to also be producer. You know, think about problems and come with a way to solve them in a customized fashion that works for not only us, but that can be adopted by everybody else. So it's really something amazing. And I believe some people on the call have been inspired by this to not only consume, you know, leverage on every tool that are there, but also think about how we can also contribute to the entire data engineering community landscape, you know, by bringing about solutions like this. And, you know, we can also be well known for that. Also, as regards the source code, so Nelson has shared the repo on the GitHub repo on the Teams chat. So I think we can all review and, you know, come up with suggestion on how we can improve this. And I don't know if there is it's open for, you know, pull request and, you know, people, if it's properly open sourced. I don't know about that, Pascal. Oh, yeah, your mic is
I
muted.
think that's I think that's something we might have to do. I'll get back with the team and see how best we do this. Obviously, the whole point of this is to make it open source so that many. I mean, we only did Mongo, right, to a Postgres destination. We have Dynamo out there. We have so many other source destination source DBs that we can put in there. So the more of the community that helps do that, the better prolific it can get.
Yeah, exactly. That's what I talked about as well. Yeah, I mean, amazing stuff. Thank you once again, Pascal, for coming to the call. You know, every time you're always willing to come and speak to us, and we appreciate that. Any question? So I'll just quickly check the chats if there's any question. And please, if you have a question and you want to speak, please raise up your hand so I can call you to speak before we round up. Currently loading the chats now. Okay, the GitHub link will be reshared. So I also shared I'll share it in the community. Or Nelson can help us share in the data engineering community. So someone is asking, will it work straight with DocumentDB?
I don't. Is DocumentDB? I thought DocumentDB is a style, right? Mongo is a document.
It's actually
exactly.
like Mongo on Mongo on I think Mongo on AWS.
Oh, okay. No, I don't think.
Mongo on AWS or something.
Oh, okay. I think it should, because I mean, once it's managed stuff, it's still that same guy. If the connections are the same, what I would say is just test it out, see what all you need is the URI. Give it the URI somewhere here and see what happens. Just give it the URI on the con and see whether it goes through for you. But beyond that, so if you are thinking about how can I make it work with Dynamo, right? If you're experienced enough, you already know what to do if you get to this report, right? But all you need to do is to bootstrap this class. That's all you need to do. Just go into this class. You can see how you can add more sources to it. Simple as short. On the loader, you go into it and see how you can add more destination. If you wanted to do more than flattening or not to touch it, you're interested in actually taking it to the data lake, go into data extraction, make it not to touch it, dump it as you see it. And that's the way you can make it ELT. That was actually how it was planned.
Okay, Ahmed, is that fine?
Yeah, it's fine. It's fine. Thank you.
Yeah, I actually thought of putting a GUI to this thing, right? We want my kids' assignment because I mean, just a box, because all you need here is to click and that thing starts running. Okay, but I don't want to put my energy on somewhere that might not be the core of the thing for the functionality, but GUI, yeah, still works.
Yeah. Mayo.
I think someone has his hand up. Yeah.
Oh yes. Again, thanks for the session. Please, are we going to have access to the, I think there's a diagram there, or a chart whereby you said how this works under the hood, or this guy there.
Yeah. Najeeb,
Yeah.
hopefully you share them. Yeah, you can
Yeah,
actually
I'll
have
do
this
that.
slide.
Yeah, so I'll share the slides, I'll share the repo link, I'll share the notebook files used as well. I think you need to share the updated one, like, because the one I have, I think the details also missing.
Oh, it's not there, right? Yeah, I will share that with you so you can
Yeah, the
check that.
updated one,
This
yeah.
image was actually made by Nelson. So I mean, don't think I might have started this try to, but I have 2 persons who work with me on this, and I encourage us to also, I mean, share ideas with them. Let's see how we can make it better. It's not about it's not good or like I'm trying to claim ownership. No. This is community stuff, and this is how good stuff really needs to work. And sometimes putting it in the community actually makes you have subpar stuff. Yeah, that's true. But once there are good professionals around, we can make sure it's tight.
Exactly, and which is why I asked the question if this can be open source, because things like this is something we should encourage among the data engineering community, to just bring about ideas, inspirations, and see how we can also come up with stuff that's beneficial for us and everyone at large. I mean, it's a good initiative and it's something we should support going forward. More of this. We need to have more of this.
Yeah, I
So
think so.
and Joe and Nelson are very well integrated and part of us. I mean, so yeah, that's fine. Mayor, is it old hand or new hand?
No, definitely the old one.
Oh, okay, just to be sure. Just to be sure.
All right.
I mean, I think the question I would just ask is, for me, I always like to be the devil's advocate.
I was actually
Yeah,
asking whether there is none here. I love them.
Yeah. So me, I'm just going to ask you, I mean, so what are some of the challenges in implementing incremental data pipelines? So, I mean, there is nothing that is 100% good or 100% perfect. So there's always be downsides to stuff. So, I mean, while building this, what are the challenges you face? And generally, what are some of the
Now, depending
challenges
on
in implementing data pipeline?
Okay, generally, your incremental pipeline. So sometimes I see people mistaking it for streams. The incremental pipeline is not a stream. Okay, it's not. The aim, if you think about it very well, is not to be 100%. The lapse between your source and your destination, the whole point is not to make it 0. No. The whole point is to make sure that you are up to date to X hours, to X minutes, right? And the first challenge you start seeing is that if you want to make it a stream, you start overlifting. That's one, but it's not a real problem. But the real problem is that as your organization grows, you might find out, so where MI-ETL, for example, prices itself is that it will never, what you are moving will never get beyond a particular size. And that's exactly what matters, because big data makes it such that the finest pipelines are put to shame, because the sheer size of the throughput is going to make you think whether there was any engineer on it. So incremental pipelines allow you to break them down. But as you are growing bigger, that incremental stuff that you are moving 5 MB with 5,000 customers, your company could grow to 100,000 customers or 1,000,000 customers. I mean, think people who are in e-commerce. 5 MB could immediately, suddenly grow to say 100 MB. And if you have not planned well, if you deploy it as a serverless service, it starts breaking because it can't finish the 100 MB before it times out. But you always finish 100 MB. It's too small. Just saying you get to that point, your incremental load starts having a problem. But there's something you can do. If you're running it every 24 hours, it's telling you need to start running it 2 times. Because if 100 MB is coming through in 24 hours, if you break it into 2, it's 50. So as it's getting bigger, you are having more run times and you are going to take care of it. That's the first thing I think could work against you in an incremental pipeline.
Okay, absolutely. I mean, absolutely. Mayor, is this older on your hand?
Man, it's the old one, and I don't know how to uncheck this.
Yeah.
Okay,
No,
okay,
it's
I have
tough.
to click again, man. Sorry.
You're probably a Google Meets person.
Yeah, exactly. Exactly.
Mayor is a good meet. You got it right. Okay, that sounds good. So another question is, you talked about the updates. So what about situation whereby there are deletion as well from the data source?
Yes. So when something is deleted from the source, did we handle that? I remember I have a plan for it, but I can't remember whether we handled that. But this is what it's going to do. Uplog, yeah, it does. It does. Uplog actually gets a record of what went away. That's how beautiful Mongo is actually. So your uplog is going to tell you about deletions actually. So it picks up the deletion, and what matters there is the key. So when it goes to the destination, it finds it, removes it, and puts the ones that are. But I'll have to confirm whether it handles deletion. I don't know. I can't say for sure now.
Okay. Okay, sure. Because that's something that is very important as well, because there are different behaviors of data sources. so that will make it more robust. Yeah.
Exactly. So, but the thing is, if you look at real cases, depending on the type of certification a platform has, you almost never delete data. It's always bad practice. Even when a user has said delete my data, you usually archive. I mean, let me not shout, right? Anytime you go to a platform and you do delete, those guys, no, it's not just that they don't want. Even by data rule, for a request by a customer to delete data, data regulation requires that you keep it for X amount of time before you eventually exchange it. I hope we all know that, right?
Yeah. So yeah.
Yeah, go ahead.
Oh, sorry to interrupt. I thought you had. So yeah. Sometimes you don't even directly connect to the transactional data source itself. So it might be a staging environment that has been provisioned for you to connect, and because of growing data, imagine you are working with millions and data growing to billions of records. So the staging environment, we want to retain have data retention policy on that staging environment to just manage resources and everything. So that's what I'm talking about. So not necessarily connecting to the transactional data source, but there might be some situation whereby your data source is not, so it might be a staging environment that has been maintained for the data retention policy stuff. And data needs to be deleted.
Yes, I understand what you said, but if you find this setup, that's a wrong move. You want your source, and you can see why I'm saying it's wrong. Maybe that's why Ahmed is raising his hand. You can't give data your staging environment. It has to be a replica. But I understand that there could be deleting needs, right? But where your data is writing from cannot be the staging. You might be smart enough, don't touch the actual transaction DB. What you usually want to do, what I would advise is to have a replica of your transaction DB, because the less calls you have, I mean, that's the whole point about caching. Core engineering is trying to cache to be faster, and you, the data engineer, is trying to connect directly to them. If I'm part of that team, I won't tell you don't do that. So get a replica, not a staging. Tell them it's not staging. Nothing goes away from there, because it's trouble waiting to happen. It might not happen in the first 5 years, but one day it will happen and Wahala go bust.
Yeah, I mean, yeah, I get. So don't flog it too much. So the only idea is just to, of course, it's not impossible. So I've seen situations like that, whereby the environment you connect to is not the source itself. So it could be many reasons. It could be to, say, for example, in source, it's so robust that you have hundreds of tables, and usually the reporting tables are different from the core transaction tables. So what you usually need to connect for as a data analytics team is the reporting tables. So you don't want to then have an entire replica of a transaction database, of which you are only connected to maybe 5% of the entire table in the source DB. So the staging environment is then provisioned for report analytics sake, so that you only have the required tables for analytics in that staging environment. You understand? So just different situations, different conditions, you'll be amazed that there are some environments like that whereby the source itself, it's not, and it's not even advisable to even connect to the traditional data source. So you want to always have maybe a replica staging or something like that, so you don't contribute to the load on the production transaction DB. So yeah, so that's what I'm asking. So we want to check also to take care of that situations.
Yeah. So it appears you have seen something like that, right? So let me throw a question. Yeah, you have, because I mean, I see the way you say it shows you have, right? I will tell you why I think there's a problem with that. So let's say you are using MI-ETL. They remove some, get removed there just to manage it. MI-ETL will want to reciprocate it and go and kill it in the destination. Do you see what you just caused? You see that? That's why I'm really surprised that some people would do that. Maybe the thing is, what's tripping me is that maybe you're using the word staging, right? Because as a core engineer, when you say staging, we are playing there, right? Maybe you are just saying
Yeah, it
for
can be.
data.
Yeah, it can
I
be
understand.
used.
Yeah.
Yeah.
Okay. Yeah. But I understand. But just think about it. If you remove that and your pipeline will want to do the same thing, suddenly your destination will lack data. So maybe, but if the system, the platform engineers understand that this is what's happening, they will always take care of it. For example, ask MI-ETlx here if there's a decision bonum, something
Okay.
like that.
Yeah. So you don't flog it too much. I mean, just to bring that scenario, like I
Yeah,
said, I'm
yeah,
always
the
the
possibility.
devil advocate. So
Yes,
so
yes.
that is a scenario that is rule. So it's possible. So
Yeah.
yeah. Okay. So you don't flog it too much. Anybody else before we let Pascal go? We always want to get as much as possible from Pascal. Okay. So I
So
think
can I
there is
just
no long.
before you go, one more thing? I
Okay.
think about the deletion or delete. I think since it's working with uplog, I think uplog has a flag for delete already. So I think it will have been implemented.
So
It has a flag for
it
it.
does. It does.
Okay, yeah, okay, that's fine. I mean, just coming from the mindset of trying to have every view of possibilities, because it's not
Yeah.
something that is built only for
It's the best
MongoDB
mindset.
or
Yeah, it's the best mindset because don't deceive yourself thinking it will always work. It's a lie.
yeah,
It
that's the only
must
situation.
break.
The only situation that
Must
we've
break.
created.
I agree. Correct.
There will be some situation that even though it doesn't make sense to you, it makes sense or doesn't make sense. At least it's possible. It exists.
Yeah, your village people are never resting. I mean, they're always going to the markets. You can't do anything.
Yeah. Okay. Thank you so much, Pascal, once again. Thank you everyone for joining us today. So much appreciate. So like I said, the resources for this webinar will be shared in the communities. So expect that this webinar is also recorded. So we'll be sharing the link in case you want to go back to it and for other members that are not able to join. We'll also be having another episode next month. So this is a monthly webinar series. Do watch out for that. So it's going to be impacting as well. And we'll share more details as regards that as we approach next month towards the webinar. Pascal, I mean, we can't thank you enough for always showing up and coming to share your wealth of knowledge with us. We can only appreciate you. We can only, thank you for all you are doing. So, and like I said, this is a very good initiative. You can see people appreciating you already with different love emoji and clap emoji. Yeah, so well done. Well done to Pascal and Joe as well, contributing to this great project. And like I said, we'll try, share the repo, people review it, and we bring suggestions and contributions on how we can make it better. And not just this, how we can also collaborate and, start working on projects like this to help the community grow. So thank you so much once again. Pascal, I don't know if you have any parting words before we close this session.
Yeah, thanks for having me. Always fun to be among engineers, young engineers, not old ones like us who are dodging things up and down, right? Kudos.
All right, thank you. Thank you, everyone. Enjoy the rest of your weekend. Have a wonderful evening. Bye, everyone.